Excellent. I'm happy to see you all.
I'm just giving 1 more minute and then we can go and start. Got people all around the world today. Brazil, Barcelona, Spain, the UK, South Africa. That's good to see. Boston, nice. Okay, 1 minute has passed. I think we can go ahead and kick off this meeting. Okay, so welcome everyone. This meetup is dedicated to exploring the future of decentralized identity with Hyperledger Identus. I'm actually super happy to see we have an awesome turnout today. That's really positive. So as you guys might know, Hyperledger Identus is a platform designed with versatility in mind. So if you guys are looking to integrate decentralized identity solutions into your application, you have to look no further than Hyperledger Identus. So for those new to this space, Identus does provide a powerful and intuitive way to confidently integrate decentralized identity into your applications, ensuring you stay ahead of the curve and leverage the full benefits of this innovative technology. While we do share some features of Hyperledger Aries, Identus was developed independently and utilizes the non-creds open specification. The platform currently uses the Cardano blockchain as its VDR, reinforcing its robust and secure framework. I know you all will have multiple questions, but we do have a pretty jam-packed agenda for today, and we do have a slot for Q&A at the end, so please keep your questions for the Q&A slot. I'm pretty sure you guys are, so as you can see, this is agenda for today. We're doing some welcome and introductions, which we just went through now, a brief history by Lohan Spies, a technical overview on our solutions by Yurii. Then we have a demo from Javi and a demo from one of our community members, C-Sign, and then post that we'll have the Q&A and closing. So I know you guys are a little bit sick of hearing me today, so without further ado, I'd like to hand over to Lohan Spies, who will be walking us through the past, present, and future of Identus. Lohan, over to you.
Awesome. All right. Hi, everyone. Nice being here. I'm just going to kind of ping you when we can skip slides. So I know about the history of Identus from Atala before 1.3.3. By that time, it was really a primarily academic exercise. It was more research exercise that ended up in a technical implementation. But the problem that we had back then is that the solution didn't comply to any of the kind of standards and specifications that we currently use and are widely used in the self-sovereign identity space. So the components that we had back then is we had a Prism node, what we call Cardano as a VDR. That is effectively a layer 2 proxy that allows you to interface into the Cardano blockchain to specifically ledger or anchor DIDs on the ledger. And also in the old Prism or Atala 1.4, we also used the Prism node for verifiable credential issuance, verification, and revocation. So back then, we also didn't have all these different components that you will see that we have today in the new Identus platform. Back then, we had one SDK. That SDK was utilized for backend development, front-end development, mobile development. So it didn't really matter what you wanted to develop on Atala 1.4. You always had one SDK that you had to use to build applications on. The features that we had available back then is we had DIDs. It was only on-chain, no, I'm lying, it wasn't only on-chain DIDs, but it can do on-chain DIDs or off-chain DIDs. We call it published or unpublished DIDs. You could also back then, and you can still do it today, you can also anchor a single DID in a Cardano transaction, or you can do batch creation. So meaning you can create multiple DIDs and anchor them all in one Cardano transaction as a batch. It was only utilizing SECP 256K1 from a digital signature perspective. And back then, we also had no DID, formal DID method registered in the DID method register. From a verifiable credentials perspective, We leveraged JSON to issue verifiable credentials. All the credentials, if you issued 1 or 10 or 1 million, it didn't matter. All those credentials was anchored on chain utilizing a Merkle tree concept. So if you issue 1 credential, you had to pay for the transaction. It will create a Merkle tree containing of 1 credential. If you issued 100,000, it will still be 1 transaction, but all 100,000 credentials will be in 1 Merkle tree. And that basically allowed you to do what we call batch issuance. Revocation was also on chain as part of a Merkle tree structure. And back then we also had no W3C verifiable credential data model compliance at all. From a communication perspective, how you actually move verifiable data between 2 peers, we had no public or publicly accessible tool to do that. So people had to figure out how to move these credentials between 2 parties by themselves. We did have an internal product or component called Prism Connect. So what Prism Connect effectively did is you go to Prism Connect and you said, hey, this is my DID. I want to be discoverable and I want you to leverage this DID to make connections with another party. The other party would do the same. And what this would effectively would be, it will become a massive centralized proxy containing all the connections between 2 parties. Obviously, that is very far from where we are now and the SSI principles itself. So after joining IOG, we looked at what we had in Atala 1.4 and we kind of went back to the drawing board. Wait, can you just skip the slide? Yeah, so after 1.4, we kind of went back to the drawing board and we said, okay, fine, what do we really want to achieve in terms of, at that point, it was Atala Prism. We called it Atala Prism 2.0. And we said, okay, there are a few things that we need to do to really get us up to speed in terms of what other SSI solutions or technical frameworks are doing out in the wild. So the first one of them, we wanted to be more specification standards compliant. So we adopted W3C from a verifiable credential data model. We created our own DID method. That DID method called DID Prism is a formal registered DID method in the DID method registry. And we then basically redesigned the Atala 1.4 from the ground up. So literally, effectively starting from scratch. We addressed various issues, like I already mentioned, standards compliance, the missing communication layer, and also crypto agility. And when we started designing Atala 2.0, we kind of went from a concept of we're going to define building blocks. So we have a building block that manages DIDs. We have a building block that manages verifiable credentials. We have a building block that manages DITCOM for connectivity, etc. And after we've built all these various building blocks, we then recompiled them into what we call the Hyperledger Identus Cloud Agent, and that is based on the Hyperledger Aries framework. So the capabilities that we have today is, like I already mentioned, W3C compliance. We can do JSON or JSON LD credentials. We have JWT credentials. STJWT is in development. We are conforming to a lot of the Hyperledger Aries components. So in essence, you can see Hyperledger Identus is effectively a Hyperledger Aries implementation. We only support DITCOM v2, and we also support Hyperledger AnonCreds as our kind of fourth verifiable credential format. And then we also started to include, it's not yet finished completely, but we also then started to add OpenID for verifiable credential issuance and OpenID for verifiable credential presentation. So now you have multiple credential formats. You have a registered DID method. You have 2 transport or verifiable credential exchange mechanisms. You can either use DITCOM, you can use OpenID, or you can potentially use a combination of both. That is something that's coming, being looked at quite a lot in the industry at the moment. And it effectively took us roughly 2 years from redesigning this from the ground up to where we are now, having this whole project in Hyperledger as Hyperledger Identus. The objective and one of the key differences between other Hyperledger Aries frameworks out there, there are quite a few of them. You have Python, there are Go frameworks, there are C# frameworks, etc. But what we did quite differently compared to any one of them, we provide you with all the components to build SSI platforms out of a box. Meaning we provide you with a cloud agent. Normally those are used by issuers and verifiers. We provide you with SDKs in Swift, KMM, or TypeScript, meaning you can do Android, iOS, TypeScript type wallets, or we call it edge agents. We have a mediator test suite, and then we have a new kind of, call it a refactored Prism node, just to make it leaner in terms of what it did before. Because at the moment, in Atala 2.0, we don't have any verifiable credentials on chain. So the only time that you actually are going to write something on chain is when you anchor your DID on chain. None of the verifiable credential issuance actually goes on chain. The chain have no knowledge or anchor data about credentials being issued, not about credentials being revoked. And basically, if you want to verify a credential, you can go and do a DID resolution, get the necessary information, and do verification. Atala 2.0, we then kind of morphed out of IIG into Hyperledger Labs. That was called the Open Enterprise Agent. And it was only for the cloud-based agent. The Edge SDKs, the mediator, all those components were not part of it. So it was really only the cloud agent. Okay, skip, please. Eh? All right, and now moving to Hyperledger Identus. From the Hyperledger Labs project, we basically migrated into a formal full-on Hyperledger project. That project is called Hyperledger Identus. Again, the components are effectively the same. It's a fully contained SSI platform, giving you all the necessary bells and whistles to build all the interfaces and components for end-to-end applications. Meaning, you don't have to go to, I don't know, get an open source wallet to build the wallet side, and then you need to go and pick up another backend and someone else's mediator. We provide it all out of a box. It's easy to deploy and use. We have quite significant and comprehensive documentation, from quick start guides and also guides going into all the different SDKs, the cloud agent, the mediator. So the documentation is more than enough and more than comprehensive enough to actually take any developer that takes the time to go through it to start developing SSI solutions on Identus. We also added reference SDK implementations. That's mainly on the SDK side. And the reason for that is just that people that want to build edge applications, you either give them an SDK and they need to go and do all the scaffolding themselves, or we can give them a reference implementation. It's not pretty, but it's functional. And that's the whole objective of it. We are not there to, at least in Hyperledger Identus, the aim is not to give you an out-of-the-box wallet that you can white label and put into production. We give you all the scaffolding and a reference implementation that you can then go and build beautiful UI, UX on top of, and then build products around it. Obviously, we are starting and continuing to build our community. And the objective here is really for the community not only to leverage Hyperledger Identus, but ultimately become contributors and actually utilize it in various different use cases. We also have a standing security assessment on any major release that we put out into the wild. That's standard practice in IIG. So a lot of our components will come with security assessment specifically on major releases. And at the moment, from a Hyperledger Identus perspective, we only support one VDR. For those of you that don't know what a VDR is a verifiable data registry. It can be a blockchain, it can be a distributed ledger, it can be a database, it can be a web endpoint. There's no specific requirements or detail around what it is, but a VDR is effectively a verifiable data registry where you read and write certain information to make the SSI issuance and verification, etc., seamless. In our case, we're using Cardano at this stage, but in future we will become VDR agnostic. So from a future objectives perspective, we are looking at easy adaptation by interfaces. And what I mean by that is we want to get to a point where anyone that wants to use Identus, but for instance, let's say we use the Prism, but they want to use, I don't know, the BTCR or any other DID method, that they will have some form of an interface to add the new DID methods, or an interface to add new verifiable credential formats, etc. So the objective there is really to make it one framework that anyone can leverage and add onto as they see fit and according to their requirements. The second thing that we really want to focus on, and I think this is something that can become a massive differentiator in the self-sovereign identity framework space, is scalability and performance. We know that from testing, other platforms are not necessarily as scalable and performant as we would like them to be. There are workarounds, but our objective is to, from the get-go, out of the gate, give you a highly scalable,
We seem to have... Sorry, Lohan, could you repeat
sorry.
yourself? We seem to have lost you there a little bit.
Where did you lose me?
Around scalability and performance.
Okay, cool. Yeah, so from a scalability and performance perspective, that's one thing that we really want to focus on, and we see it as a differentiator in the market. If we can really create agents and capabilities that are more performant, more scalable than others, then that is really something that people will look at and actually ultimately latch onto. So from a community contribution and uptake, like I said, we are currently the stewards of Hyperledger Identus, but our objective and ultimate aim in the long run is that we want a lot of maintainers in the code base. We want people that will come and actually add more code, add different features, different functionalities, fix bugs, etc. But that will take time, and that will just be kind of as a result of the community growing around Hyperledger Identus. Another thing that we want to focus on in future is compliance. There are quite a lot of either national or kind of European-wide. There are quite a lot of standards arriving or coming out, like EIDAS, etc., EPSI. There are quite a few of them. And the idea is for us to see, can we in future start becoming by de facto compliant with some of these standards? Meaning, if you are in the European Union and you want to leverage Hyperledger Identus, at some point in future, we might be able to tell you, okay, you know what, if you utilize this, it is compliant with ABC. Then security is obviously a big thing for us. As I already mentioned, we go through security assessments on every major release, but there are also minor release security assessments. So you can know that when you start using Hyperledger Identus, that it at least went through a fairly robust security assessment before it actually ends up in the open source code base. Then from a VDR interface perspective, as I mentioned, the objective is to become VDR agnostic, that people can plug in any blockchain, any DLT database. In fact, we already support normal centralized databases. But in future, people can then start writing interfaces to connect with other blockchains and DLTs for DIDs. And then for non-DID resources, we'll also provide an interface to create, read, update, delete, deactivate, if it's possible, if it is not immutable. Yeah, and then from a community perspective, establishing and growing a strong community. And I can see that it's actually every time that we have these calls, there are more and more people joining, which is very, very exciting. So yeah, if you have any questions, comments, suggestions, feature requests, connect with us either on in the open source GitHub repos or via Discord. And yeah, together we can not only build an exceptional framework or platform, but also enhance it according to the various requirements of all our community users. And that is me, and that's a quick overview of the history of Atala from 1.4 to 2.0, and now what we call Hyperledger Identus.
Awesome. Thank you, Lohan, for that. Okay, so you guys have heard about our past. You guys are about to see our present in an actual application and what we plan on building in the future. Now it's time to take a look at our technical solution at a high level. So for this part of the presentation, I'd like to hand over to Yurii. Yurii, over to you.
Yep. Do you hear me, guys? Okay. Thank you, Fai, and thank you, Lohan, for introduction. Hello, everyone. I'm Yurii, the software engineering lead in the Atala team, and I'm really enjoying sharing a high-level overview of our technology and, I would say, typical recipes for building your solution based on the Identus platform. So, what is the purpose of this slide? It's just a high-level overview of the languages, technologies, third-party components, and everything that we are using to deliver our capabilities of the Identus platform. It's nice to know what technologies we are using in Identus platform right now, but I believe it's much more interesting to see why these technologies are used here. So historically, as Lohan said, there were a couple of phases in the platform's evolution. And over this time, we learned a lot of lessons. Probably the main insights from this journey is that your platform should be interoperable with other SSI solutions. We need to follow the standards of W3C Identity Foundation, Trust over IP Foundation, and other markets, other players at the market like Areas and I don't know, other solutions. And it's essential to collaborate with community because we can share our ideas and keep our standards at the same level as current SSI market. Secondly, we figured out that maintaining the code base in Kotlin for all platforms, as it was in Atala 1.4, is really headache. It's really hard, especially for iOS mobile applications. And Kotlin cannot be a silver bullet for all the purposes, all the platform and languages. So that's why in Atala 2.0, we decided to focus on developer experience. And we switched it to much more convenient way. It's a SDK platform approach. And that's why, I apologize. That's why currently we have 3 different platforms, probably similar like Areas for Python, .NET, and TypeScript and JavaScript. Currently, we're covering 3 platforms. It's Kotlin for backend and Android, Swift for iOS, and TypeScript for convenient web application development and integration. Third item, as Lohan mentioned, agent-to-agent or peer-to-peer communication is essential to any SSI domain and solution. That's why we added DITCOM v2. We skipped DITCOM v1 version in favor of v2 because difficulties and the backward compatibility between this version of DITCOM is missed. And we added mediator to the platform. Over the time, we also figured out that it's really hard to find the perfect mediator. We tried to use a couple of mediators and ended up with a solution that we need to implement our new mediator, DITCOM v2 compliant in Scala. So that's why we have a brand new mediator, and it's a pleasure to receive your feedback about your experience of using this mediator. And probably the fourth insight is that it's pretty obvious. Don't reinvent the wheel or use well-known existing components. You can see Keycloak, Postgres, MongoDB, and HashiCorp Vault in the following list of third-party libraries and components that are currently using. So based on our expertise in the SSI domain and the experience of the current engineering team, we came to the following technology stack. Just a short summary. Backend, it's 3 services: mediator, agent, and prism node, written in Scala. We have libraries in TypeScript, Swift, and Kotlin to cover mobile applications, and it's represented as Edge Agent SDKs. We have a couple of cross-platform libraries written in Kotlin because there are particular cases when Kotlin is really powerful. For instance, we have Apollo library that is a cryptography library and is used as an abstraction everywhere in web, mobile applications, and in backend services. We decided that it doesn't make sense to reinvent authentication and authorization. That's why we just decided to use Keycloak, and secret storage for Cloud Agent is HashiCorp Vault. I don't know if you're aware about the service, but it's also open source, written in Go language, a pretty popular solution as a service or secret store. And classic Postgres and MongoDB are currently on our technology stack. Next slide, please, guys. Yep, and it's absolutely possible to build probably any SSI-related solution based on the Identus. So it might be kind of identity wallets for mobile, for web applications. It might be just a web application that use a Cloud Agent REST API in order to deliver particular solutions. It can be some kind of dApps or DeFi applications or integration solution with existing SSI platforms. As we are interoperable and we follow the same standards that the SSI community does, I don't want to say that we are 100% interoperable, but I would say that 90% we are interoperable. And we can build whatever is a boundary of your imagination. But it's really important to figure out, is it going to be a managed or unmanaged solution? I mean, who is going to manage your private keys? If you are building non-custodial solution or some identity wallet, then you definitely need to use Edge Agent SDK in Kotlin, Swift, or TypeScript for a web application. If you are interested in custodial identity wallets, which is really convenient for some big organization like a Ministry of Ethiopia or any other government that has a couple of departments and can issue different credentials in the same way as verifies as credentials for other purposes. So it's definitely custodial identity wallet. You need to use Cloud Agent with multi-tenancy functionality and use Edge Agent SDK for mobile applications that can consume this solution. And if you have interesting requirement to be able to integrate with Web2 services, existing authentication provider, you definitely need to choose OpenID and some connectors like OpenID for verifiable credential issuance and verifiable presentation. So here we have a Keycloak, special plugin for Keycloak, and the same set of the components. Probably that's it from my side, and please ask your questions after a nice demo that Javier is going to present. Thank you, guys.
Awesome. Thanks for that, Yurii. That was a great high-level technical overview of the components. So I think it's time we show you how it all comes together. So on to the next part of the presentation. Javier has been so kind enough to pre-record this. As you guys know, the demo guards sometimes don't play well. Just drop a thumbs up in the chat if you guys can hear this presentation.
Welcome everyone to the first Hyperledger Identus meetup. This is the first meetup that we are going to do in the Hyperledger community. We are extremely happy to be presenting this to all of you. So during this presentation, we'll be showcasing a demonstration of the Identus issuance and verification flow.
Just let me know if it's a little bit better now.
Using DITCOM-v2 and unencrypted credentials. A little bit more interactive because we are going to have two browser instances and one of the holders is going to act as...
Yeah, I am getting started from over, sorry.
Hello, welcome everyone to the first Hyperledger Identus meetup. This is the first meetup that we are going to do in the Hyperledger community, and we are extremely happy to be presenting this to all of you. So during this presentation, we'll be showcasing a demonstration of the Identus issuance and verification flow using DITCOM-v2 and uncreds credentials and all our ecosystem components, including the Edge agent, the Identus Edge agent, the Identus Cloud agent, and the Identus mediator. During the first part of the session, I will be covering the required steps that we need to run in the issuer API in order to create the DITs, create the credential schemas, and the credential definitions for the uncreds flow. And then in the second part of the presentation, it will be a little bit more interactive because we are going to have two browser instances. And one of the holders is going to act as just as a holder to receive this uncreds credential. And another holder is going to act as a verifier to request that holder to disclose specific attributes from his credential. Okay, having that said, let's get started. As we said, we are going to start on the first side to create the required things on the agent, on the issuer agent to issue that uncreds credential. So we are going to first create the DIT, publish the DIT, use that issuer DIT to create a credential schema and a credential definition that are related to uncreds. So yeah, let's get started. The first thing that we need to do is create a new long-form prism DIT that is not published. And then on the second one, we need to publish that on the VDR. So that's what that operation is scheduled for. It will take some time to publish that on the prism node. And then we don't really care about it, but we can already create the required credential schema. That, as you see here, you can define what fields you want that credential to contain, and you need to be able to specify at least a valid issuer and a valid author. So that's pretty much what it is about. Then we are also going to be creating a credential definition for that schema that specifies what is the signature type and the fact that, or the Boolean flag to support or not support revocation. In this case, we do not have revocation on uncreds, so this is the only way to call it right now. And then once we have created the credential definition, we can proceed on the more interactive demo, as we will have almost completed the API calls. We still need to do an additional one, but then I will continue the demo by just directly showing the UI, and that's it. Cool, so now we have this. And what I'm going to do again is start both edge agents. And I will first establish a connection from one to each other so they can recognize each other. The first thing that I'm going to do is set up holder to identity and copy his DIT and paste it here to establish a connection with him. And on the other side, I want the other holder to set up that holder one is the other DIT and establish that connection in the other side. This is done to ensure on one side that in the user interface, you are not going to be needing to remember all these weird long names. Instead, you will be having to select holder one, which is something a lot easier to understand. So having that said, what we are going to do now is establish a connection, but in this case with the Open Enterprise agent, the Identus Cloud agent. And what we are going to do now is creating a new connection with the Cloud agent. And we are going to require to copy this out-of-band invitation. But this out-of-band invitation could also be used in shape of a QR code or any other way. What we are going to do here is just set up a human recognizable name and just paste the invitation link here. And we are going to wait until the connection is fully established on the agent side. Once we have done that, we can already start issuing a credential offer to this holder one. So what we are going to do is come to this API call that is already selecting the credential definition that we created earlier in the demo.
And it is also going to set up the following claims for the credential, which are just for testing purposes. We are setting a default email address, a family day, and a date of issuance, driving license ID, and driving class. And then on the verification side, we will be playing with these fields on disclosing some and on checking that one has or not has or doesn't have the attribute that we are requesting. So what I have just done is I triggered the credential offer, which we should soon receive on the holder one screen. This is basically asking the holder one to accept or reject if he wants the unencrypted credential and informing what are the potential claims that the user is going to receive. What I am doing now is answering or replying to that cloud agent that I do indeed want that credential issued to my wallet. And the cloud agent will sooner or later reply, as you see, with the actual credential, which I'm now securely storing on the device or on the wallet in this case. Having that said, it is important to know or to note that the unencrypted credentials obviously have zero knowledge proof and selective disclosure. So from our side, it doesn't make a lot of sense to automatically show to the user all his credential data, even it's his own credential. So we are by default hiding the disclosure of all the fields that manually need to be disclosed. And this is really like cryptographically disclosing the fields. So not even if somebody found the credential, they would have access to that if they didn't have that link secret. So having that said, we have already have the first holder with a credential. And then in the second screen, we are starting the Edge agent again to be able to request this holder to send a proof of something that we claim here that we need. So then let's go and check the credential, right? The following attributes are the ones that we have. So email address matches, and then we have driving class, for example, that is a 1. So I am going to be asking the user to send me a proof that he has a driving class of 1 or higher than 1 without telling me what is the exact number of his driving class. So I do not care if he's a 1 or 2 or a 3, but at least that he's higher than a 1 and not a 0. This is going to initiate that verification request flow that we wanted to initiate now. And hopefully at some point we are going to be receiving that verification request. And we just have a very simple selector that is showcasing the list of credentials that the user has available in the secure storage already. And we are now answering to that verification request. And very soon, the other holder should receive the DITCO message with the reply for that verification proof. And then this holder is 100% capable of verifying this unencrypted proof. Then what is happening behind? So the user is getting an unencrypted presentation, and then he's going to check the credential schemas and the credential definition that we created earlier on the cloud agent, and then it is verifying that the cryptographic proof is valid against that credential definition and that identity. So yeah, that's where more or less the demo ends. I must say that all the platforms that we currently support on the SDK support the same functionality. So everything that you see here can be done on Swift and can be done in KMM. And just to go through the UI again very quickly, we have this verification screen flow. We have the connection tabs where you can establish a connection with any of the parties that we want. We have a credential tab where the users can list the credentials that they already have stored. And we also have the messaging tab, which allows the user to check the messages that it already had or even send a basic message between each other, which is just a very easy way to start a communication or something like that. So yeah, having that said, I think that it's time to give you guys time for questions, doubts, or concerns. Thanks a lot. Hello, welcome everyone.
Awesome. Thank you, Avi, for preparing that lovely recording. I'm glad to see the demagogues didn't give you any trouble during the
almost.
Okay. So I know you guys might be thinking that, hey, the team behind it built this, but what else can be built with Identus? Well, if you're looking to sign anything, maybe verify documentation easily and certify with confidence, then CSign is your go-to tool. So enough of me rambling. I'd like to hand over to John and Roberto from the CSign team, who's a part of the Identus community, to demonstrate what they have built using Identus. John, Roberto, over to you.
Thanks, Vlad. I think if you can stop sharing, I can join. There we go. There we go. Can everyone see my screen?
Yes.
Awesome. Awesome. Thanks, Vlad. And hello, everyone. I'm John from the CSign team. CSign is a platform to sign, certify, and verify agreements privately between parties. It's built with Identus, and we're excited to show you just a little bit of it today. Let me start by just telling you what you're seeing on screen. So I've got two different browsers, one on the left over here, where I'm logged in as John, and over here on the right, we've got our fictional, but real in our hearts, user demo signer. And I'm going to share an agreement with her so that she can sign it. Now, before I get started, I'd like to talk about why CSign. If I had alluded to some of this, but you may have heard in the news recently that some high-profile e-signing platforms were compromised and their data was leaked. CSign solves this issue by leveraging the power of SSI and Identus components. And hopefully you'll get a sense of how we do that through this very quick demo. So let's do this. So over here on the left, I'm going to click Create. I happen to have a folder over here with a very highly sensitive agreement. And you can see here, this is an agreement that contains PII and KYC information and financial information and IP and all kinds of stuff. We don't want that to leak, of course. So we're going to use CSign instead of an existing platform because we want it to be private. So I'm going to upload this here. Let's close this. Let's see. Highly sensitive agreement. Oops. Okay. I'm going to give demo signer till the 20th to sign it. Call this version 1.0. Please read and sign. And so I'm going to add from contacts. Now, these are contacts. These are people that I have formed connections with, SSI connections with on the CSign platform. And so I can trust them. They've all been KYC'd, and I know because I see their profile photo, I know that Matthew is Matthew, Roberto is Roberto, and so on. So I'm going to add a demo signer to this agreement. And then I'm going to start by signing it myself. So I click sign. I'm on a Mac, so this is going to ask for my Touch ID. And I Touch ID here. And now I've signed this agreement. And over here on the right-hand side, you'll see this pop up instantly. So demo signer has now been invited to sign. So demo signer is going to click into here. And I'll point out some interesting characteristics of this page here. So first of all, up here in the very right-hand corner, there's this little bell icon. So these notifications are all sent securely over DIDComm. Okay, that's part of the Identus platform, and it's a way in which you can pass encrypted messages between peers. And as you'll see through this demo, everything we're doing here is completely end-to-end encrypted and private between peers. So the next thing that demo signers are going to want to do before they sign is they're going to want to obviously read the agreement. So they're going to click download here, and it's downloaded into my downloads. Let's see, go to my downloads, and you can see here top secret. And now demo signer can read the agreement. And when they're comfortable, and they can even verify my ID if they want to double check that I am who I say I am. However, we've been connected through C-Sign, so there's already some trust there, but they can certainly verify before. And by the way, I will go deeper into how the file transfer works in a minute. But this file is completely encrypted and then decrypted when demo signer wants to read it. And I'll go deeper in that. So demo signer is going to sign. Demo signer is also going to be asked for their Touch ID. Okay. And now if we go back over here to John's side, everyone has signed. This can be any number of signers. For the demo, I'm showing 2, but this can be a multi-sig with 50 people if you want. And the next step is to certify this agreement now that everybody is signed. And now if I scroll down here, I've got a whole nother option here to certify this agreement. I'm going to do this, and I'll explain what's happening. Right now, we are collecting all of the identity public key DIDs of all of the signers, and we're wrapping them up into a DID document, an SSI DID document, and we are then creating a hash of that document, which is a DID itself, and that is going on chain. And we wait for this to resolve here. Okay. And so this has resolved. And what's happened here, both parties have been notified. And now you get this transaction hash, right? Oops. Sorry, let me go back to, now it's in the completed. Okay. Great. So now we get some information, and you can see here down the signatures that both people have signed this agreement. Now I'd like to kind of show you exactly what happened. I mentioned that we created this DID document. The other thing we did was we issued verifiable credentials to each of the signers. So let's take a look at what that actually looks like. If I copy this and I go to look at this, we create a verifiable credential. In this case is a JWT, and let's inspect that and actually see what this is. So here are our DID prisms, the subject, which is me in this case. This is the agreement URI on C-Sign, right? So this hash is the only thing that ends up on chain, actually. You can see top secret PDF. Here's the title. And you can see here the signers. So John has signed this. Here's the timestamp. Here's the proof of my signature. And down here, Demo has also signed this, their timestamp and their proof. Okay. Right now, this is a W3C VC. But with Identus, this can be an STJOT or encrypted verifiable credential as well. So the other thing that C-Signs allows is to make everything verifiable. So just to prove that this is not just text on a page, if I click here, we can see if I want to verify this agreement and signature, here's my DID, here's the proof. And there's a little verify tool just to see that it's actually active. If any of these change, this will show red. You can imagine this being a third-party API or something where somebody else can verify the legitimacy of signatures and an agreement. And once things are signed, you've got these completed documents you can come back to anytime. Now, that is C-Sign. I am going to, let's see. I want to talk more about the file transfer that I sort of briefly looked at. So everything here, our goal is to have 100% privacy. And Identus allows this in many different ways via SSI. But one of the cool things we have is DIDCOM. And so if you look on the lower left-hand corner here, the creator, I'm going to explain how that file upload and download actually was working. So the creator uploads this document, and we generate keys on the creator's client, right? In this case, it was a web browser. It could be a mobile app. And we encrypt the file on the client. So if you follow the diagram here on the left and go up, you'll see the document is uploaded. In flight, it's already encrypted, and it ends up on the web or file server. And so it's an encrypted blob there. The keys are not stored with the document at all. So if CSign were ever to be compromised, or any of your file or web servers would be compromised, users or hackers would only see a bag of bits. They would not be able to decrypt that stuff. And in fact, in the future, we will support other file and web servers, platforms as Google Drive or Dropbox or whatever. You can sort of point it to your own storage of choice. And so it lays there encrypted with no keys. When signer wants to download that file and view it, they click download. The encrypted file is then sent to the client, and now signer needs to be able to view it. And in that case, a request is made over DIDCOM. The creator sends the keys directly to the signer, never going through CSign servers or any other third-party servers. And that's how signer was able to actually open up that file and read it. The keys were sent P2P, or as what we're saying is D to D, did to did, and that's over DIDCOM. So real quick recap of what you've seen right now. CSign is private by default. It's got a simple, friendly UX in which we've abstracted all of the complexities of SSI. There were no QR codes. You just log in with a password. Everything has been taken care of to be completely encrypted. We are both end-to-end encrypted and peer-to-peer encrypted. All the data remains private between creators and signers. In fact, CSign can never read any of your data. And everything is cryptographically verifiable. And this is all built on top of Hyperledger Identus and its components. Real quick shout out to our team, Matthew Marino, our founder, Roberto Carvajal, our lead engineer, and Mal Som, who's crafting all of the beautiful experiences you're seeing. Thank you so much to the entire Identus team. It's a wonderful community. You should totally join the Discord. If you'd like to help CSign out at all, the best way to do so is to support our Catalyst proposals. You can find out more there by going to csign.io/fund12, and you can see a little bit of our roadmap there and how you can help us. You can certainly always send an email to contact us. Our Twitter is down there below, and the website is there. Thank you again for your time.
Wow, awesome. That was a fantastic presentation. I don't think I've seen CSign since our last meetup that we've had. You guys have come a long way.
Thank you, Fayed. It's been you guys have been a true help in every sense of the way. It's a great community.
I'm glad to hear that. I'm sure the team loves hearing that too. Okay, guys. We've come more or less almost to the end of our presentation. We do have a Q&A section now. So are there any questions in the chat, or feel free to raise your hand and come up on screen and ask your questions. Fantastic demo, nice comments, really good product. Thanks for the session. Thanks for joining, Jim.
Hi, Fayed. I have a question or two, if I
Awesome.
could.
Yeah, go for it. Go for it.
I work with the government of British Columbia, so I'm familiar with the Hyperledger Aries, Akapai, and OnCreds, all those kind of solutions. And I'm curious with this Identus, what kinds or if you have any production implementations using this. And then the second question would be, what level of interoperability with other Aries agents has been tested?
Okay, sure. In terms of production used use cases, Nishka, are you on the call? Do you maybe want to take that one?
Sorry, Faye, what was the question?
Production use cases using Identus.
Yeah, so at the moment we have a team called Socius in the Cardano network that has a production use case that they've already launched. Fayad can stick the URL in the chat for you. We've got another team called PLP. They're in production, but they haven't launched yet. Those are the two that I'm aware of that are on prod.
Yeah, part of my question is what kind of use cases are you seeing with this solution kind of as well, even if they're pilot, maybe not production, but yeah.
Yeah, the PLP one is an education platform where they're issuing credentials for completing learning. And the Socius one seemed to be a learn-to-earn type platform. Yeah, learn-to-earn. But I haven't gone through the platform in depth, so I can only give you the high level.
No, that's great. Thanks. And then for interoperability with other Aries agents, have you tried anything there or tested anything?
Lohan, do you maybe want to take this one?
Yeah, so from a Aries interoperability profile perspective, version 1, version 2, we have it on the roadmap to do it. It's most probably something that will come up soon, but at this stage we haven't done any formal testing against any Aries interop profile or any Aries specific agents yet. One of the key reasons is that a lot of the current Aries agent don't necessarily support Bitcoin V2, and we only support Bitcoin V2. So we need to do some work to create some kind of transform layer if we really want to test interop with other agents, specifically over Bitcoin. But yeah, at the moment, no, we haven't done any formal testing. That is something on the roadmap.
That's great. Thank you.
Awesome. Thanks for that question, Carl. Any other questions at the moment? Shailesh, go for it.
I had one question for the C sign actually.
Sure.
Do they support, do you guys support amendments? So, for example, if someone is not happy with that document, what happens in that case? How do they ask for the amendment?
Yeah, that's a great question. So right now, C-sign is sort of the finality of an agreement. We have this idea of versions, and you can iterate a version up until the point of certification. Once everybody signs and you certify, that's intended to sort of that's what actually gets written to chain. So after that, you would have to nullify that agreement. But up until then, you can sort of handle any versions before that.
Thank you.
Cool. Thanks, Shailesh. Any other questions on the call?
Hi, Vinayak here. Am I
Hi,
audible?
Vinayak. Yeah.
Yeah, so I have a question about, let's say, an application where the issuer and the holder is the same and they are hosting it on the platform. So can we use Identus for that application to have only specific blocks, let's say verifiable credential block of Identus is what I'm interested, but not the DID com or other aspects. So is it possible to do that?
Sorry, could you repeat that? I'm not sure if I caught that question.
Yeah, so I mean, only certain building blocks of Hyperledger Identus, like only the verifiable credential part, is what I'm interested in, let's say for my application, and not DID com or other components or other building blocks. So can I only take some aspects of it which are essential for my application and build?
Sure. Okay. I think I understand what you're saying. It's maybe something someone from the technical team would have to answer if that is possible. Lohan, Javier, Yurii?
Yeah,
Maybe.
really quick. I would say that you would be in this case on your own. So the holder SDK, so the Edge Agent SDK does not provide issuance capabilities. But then issuance is all about creating a credential and then anchoring that on chain and having a revocation registry that allows you to revoke that credential. So yeah, it's potentially doable, but we do not support that yet. On top of that, I would say that if you would be okay by having a custodial solution, and for your use case, having a custodial solution is good enough, then you can basically build what you are saying. And it's just that the holder would be in custody of the cloud agent. And you would not care so much if it has DITCOM or not, because it would work inside the agent. So yeah, that's kind of your question, but it's not currently supported, I would say, or not our main focus.
Okay, okay. Can you please elaborate a bit on custodian agent part of it? Like what is custodian agent and what is not? Like,
So what we mean here is that keep in mind when the demos that I've shown, the browser instances, what we are doing there is we are generating the seed on the front-end side. And then what I mean by a custodial wallet solution is that there is a functionality in the cloud agent where you can create holder wallets and then use these holder wallets to store credentials and run through all the flows that you've seen, but just through an API with its own tokens and all that.
okay, okay. Got it. Thank you.
Welcome. Thank you. Any other questions on the line? Check the chat as well. Nothing. Okay, there's no more questions, guys. I think we've come to the end of our meetup. I do want to thank, I do want to give a shout out to the amazing community for coming out and showing their support, and the amazing team behind Identus. Without you guys, I definitely think we wouldn't be where we are today. Sorry, I do see a couple of questions, maybe some comments in the chats. Oh, got it up. Thanks. Yeah, love you, fam. If you guys do want to get involved, I highly suggest you join the Discord. I am posting a link to the Hyperledger Discord over here. There's Identus channel. Feel free to come and ask us questions. And we also do have meetups on it. Sorry, not meetups. We do have calls on a Tuesday. Next week, Tuesday, will be the maintainer and contributor call. And then the week after that, we do have the community outreach call. So it alternates every week. So if you guys do want to get involved, check out the Hyperledger calendar, add it to your calendar, and we will hopefully see you guys at the next call on Tuesday. Thanks everyone for joining, and I look forward to seeing you all in the future.
Thank you.
Thank you so much.
Thank you, guys.
Thank you.
Bye-bye.
Bye.
Bye-bye.